thank you for being here. I've been lucky enough to travel around in this country for over a month now. I'm really humbled by the hospitality of the people here. I've had a lot of great experiences, and I arrived in Delhi yesterday, and I was able to get some amazing street food, and I was able to see like the modern art museum. It was just overall so far a great experience. As was already told, as you already said, I am a consultant. I'm also a web developer. I work a lot with Neo4j. I developed a PHP driver for them, and I help a lot of clients migrating from SQL databases to graph databases. And before I actually want to start to talk about the technicalities and start actually explaining what graph databases are, I just like to give a key takeaway, and that is that graphs are all about connections. And real life is also all about connections. A lot of problems model really well to graph models. And there is a nice video that was made a few months ago for Graph Connect, which is one of the biggest conferences about graphs. And I just like to show that to you before I actually start. So, that was it. So, over to the plan. So, I first want to talk just about graph models, not talking about databases or anything, because this will be an introductory talk. I will just assume no prior knowledge before we get started. Then I will tell you how graph databases leverage these models to become something useful. And I will show you a little bit about the query language, which is called Cypher. And I'll do a very short workshop to show you how the database works. And then I'll invite my colleague Sid on stage, and he will explain a lot more about the company and why Neo4j can be a great fit for you. So, on to the introduction. I actually like to talk a lot about like the history of these things, because we are all taught that relational database models are like ancient. They are the things that have been around since forever, 6 years ago actually. and they are like considered to be like the most stable technology. And in a lot of ways, it is true. Like the SQL technology or the relational database model has been around for 6 years. But if you go and take a look at just from a mathematical standpoint and thinking about graph models, these things are actually a lot more older. Like they have been discovered, graph models, 300 years ago by this guy. This is Euler, Leonard Euler. I hope you've heard of him. He's like one of the greatest mathematicians of all times. Of course, because it was discovered 300 years ago, and people started to think about it from a mathematical perspective for so long, that actually makes it almost 250 years older than relational database models. And the way he discovered it, like again, I'm not a licensed mathematician or historian, so I'll be giving like a loose interpretation of the story. But almost 300 years ago, there were a bunch of rich people in Koningsberg. They were having their gin or their coffee. I don't know what they were drinking at the time. And they were just thinking about a seemingly simple question. In Koningsberg, there are 4 islands and 7 bridges, and they were just wondering out loud, would it be possible to walk across every bridge only once? So you would not be able to stop, teleport, go over the same bridge once. It would be one continuous route that would just hop over every bridge once. And it actually was a problem that stumped a lot of the greatest minds of the time. Until, of course, Euler came along, and he used his Sunday to simplify the problem. So he looked at the map and he saw the 7 bridges and he said, I can actually simplify this and make every island a dot and every bridge a line. And you would get something which actually is considered a graph. And he realized we can either look at this as a numerical problem and we can go over every possible solution, but that would actually already be a combinatorial explosion. And with the tools of the time, it wasn't possible to prove it that way in a reasonable time. And further than that, even if you were to brute force the problem, it wouldn't actually teach you something. It wouldn't be something that would scale. So he looked at that simplified graph essentially, and he was able to make a lot of generalizations. And he realized that these connections are actually the most important part of solving the problem. And thinking about it in that way, he was able to prove that it wasn't possible to traverse all the bridges only once. But he was also able to generalize it. He was able to say if 2 of these nodes had an even number of bridges and 2 other nodes would have an uneven number of bridges, you would have to start at a node with even bridges and you would be able to walk across every bridge. So he was able to generalize it in a lot of ways. And he actually discovered 2 new branches of mathematics in an afternoon. He discovered graph theory and he discovered topology that day. So that was a great day for all the mathematicians out there. But that, of course, has been 300 years ago, but we are using graphs actually in our daily lives. This is a metro map of Delhi. So actually, if you are wanting to go, for example, to the airport, and you would live in, let's say, Shaltara, I'm sorry if I'm mispronouncing this, but you would automatically start to take a minute. You would say, okay, I take it to the direction Rikala, and you would keep going until you cross with the yellow line at Kashmir Gate. And then you would just go to New Delhi, and then you would follow the orange line all the way until the airport. There are, of course, different ways to do this. You could go, you could take another road and go via the blue line or whatever. But just without thinking about it, you've done a pathfinding algorithm. So you use it in a lot of ways in your daily lives without really realizing it. So if you want to go to the core of what is exactly a graph, it's actually really simple. This is the simplest graph I could ever think of. It's 2 dots and a line. The lines we call nodes or vertices, like nodes in database names, and vertices is like the mathematical name. And the connections are a relationship or an edge. Again, database language or mathematics language, they're interchangeable. So I can hear you think, about, okay, this is nice, this looks interesting, we've learned about these bridges, but how essentially would I be able to build an application out of this? How would I do something useful? How would I do data science with this? And that is, of course, where graph databases come in. And they make these models useful. First of all, by using the nodes and allowing people to use to add properties to them. So properties are essentially key value pairs, and you can assign any value to that, like string values, binary data, temporal data, geospatial data. It doesn't really matter. And you are allowed to give them labels. And labels are essential because they provide schema optionality. It's a schema optional database. So that means you don't have to define anything on there, but you are allowed to define constraints, indexes for better lookup speeds, managing performance, all these kind of things. And then if you talk about modeling, if you want to realize, okay, I'm gonna design my database and I'm gonna use graphs for that, how would you need to think about that? Well, I would argue that if you're solving a problem, nodes are what directly translates to nodes, because nodes act upon each other. For example, which actor plays in this movie? An actor in the movie would be a node. Same with the other questions, how many movies did this director direct? And which users rated movies more than 4.0 out of 5. Just quickly going over them, like, okay, why would you use properties? First of all, just for uniquely identifying a node, you can add IDs to that, UIDs, whatever you want. And these things can help you with either anchoring, navigation, or output. I talked about pathfinding algorithms, and they are essentially the bread and butter of graph databases. And they will always have a starting node. And that starting node is what we call an anchor. So you would say, for example, start with all the nodes that are red. So all the red nodes would be an anchor to find all the paths, which we'll go over that later. They can also help with navigation. For example, saying, I only want after that blue nodes, and they would filter it for you. And then finally, to do something useful, you need to be able to output the data and project it. You can collect information, just return certain properties. You can do essentially anything your heart desires as a developer or a data scientist. Then the most powerful feature, I honestly believe that this is like a unique selling point of graph models. There are the relationships. And they are the physical connection between the nodes. That's different from relational models, but I'll go into that later. Again, relationships can become useful because they're allowed to have properties. They have types instead of labels, again, for schema optionality. And they connect the nodes explicitly, and they allow for a direction. So if you go back to the same examples, we'd say that relationships are the verbs. They're the ones that connect the nouns. So, and they have a direction. For example, an actor plays in a movie. The actor is acting upon the movie in that regard. So the line would be going from an actor to a movie, the arrow. Same with the other examples, like which movies did this director direct? Direct here is the relationship, stuff like this. And then, of course, combining the nodes and the relationships, we can do something very fancy called pattern matching. And they allow you brackets. So you would this is essentially asking, give me every node A that loves node B. And then if you want to use the labels on top of that for the nodes, you would again use a semicolon and then add the labels to that. So now we're asking which human loves the other human, and you would just return this. So that's the basics. If you want to become more complicated, if you want to do more complex examples, you can just reuse the same names and separate them via comma. And then if we just talk about like the basic query structure, we would say we would match the pattern. The patterns is what I just described. You would then filter that with a work query, with a where clause, and then you would use a return clause to actually say what you want to be returned. You could return the entire path, you could return properties of the nodes in the path, you can just return whatever you want essentially. So that is like the theory, the technical part, and now I just like to use the next 5 to 10 minutes to show you how these things are done in Neo4j in the database. So fingers crossed that the demo gods are on our side. Um, this is that maybe I should just first start to explain how you would add this to Neo4j, to Google Cloud, because Google Cloud actually provides managed instances. So if you go to this typical navigation menu, I believe you will find somewhere down here. Yeah, there it is already. And if you press this part, you can just add it here to our instance. There is also a free tier available for you to play around. Of course, I'm not going to set this up right now. I have already set up a basic thing. So this is your typical dashboard. If you want to look at the schema of a database, you can just use a call query, db.schema.visualization. And I think it should be loaded. This is actually a data set that I loaded of Stack Overflow. So you can see the tags here. I believe this is a question, the answer. This is what we would consider like the actual schema, how all these nodes are connected. And you can actually do this by yourself. And you can experiment with this by using the play command. And I think I have it here. Yeah. You can just use these guides. And it'll go through, it'll actually explain this to you. So this is really for teaching, for learning purposes. It'll teach you, okay, this is gonna be the model. If you want to look at the model, you can call this query, which is what I just did. This is a more complex query, but this is just to load the information because it loads it from the API from Stack Exchange. So it gives you the full example of how to do these things. And then of course, they'll start to show you more complex queries. So you can just experiment with that. For example, this will return all the labels that are available and how many nodes are in each label. So in this data set, we have 111 comments. There are 95 users, 85 questions. It's pretty self-explanatory like that. And yeah, I think I really want to show you more that these are the things that you can do, but I don't really have the time to get into the nitty-gritty of doing of showing this. This is a more complex query. I think if I look at this, they will look at all the users that provided an answer to every question, and then they will probably start to calculate the score. So those would be the top questions. And there you go. So you can really start to play around with these queries and learn a lot. But because Neo4j is not just a database, it's an actual platform. It has a lot more than just data functionality. There is also data science. My colleague will explain a lot more about that. But you can also explore the database without actually learning the queries. So there is a tool for that called Neo4j Bloom. And this is actually for fully visualizing graphs. So you can see here in the top left, I've just requested all the questions and tags, and it'll show you like this. And you can just start exploring it without ever querying. And of course, it's going to ask me to log in again. So let's hope this will, the demo got there. Yeah. Let's just start a new scene. I'm just going to refresh this. Yes, so now we've got an empty scene. So we can just start, for example, to look for every tag. So we can go like this, press enter, and it is going to return every tag that is in the database here. So we can just explore all of the kinds of tags, and let's see if there is something interesting in here which we care about. We can just use Neo4j. It's probably going to be really one of the super nodes, one of the nodes that has a lot of connections. we can just ask to zoom in on a specific node and look at all the relationships by using the expand. And it's already telling me it's going to spawn 79 nodes. So in this example, with only a few hundred relationships, this would probably be considered a supernode. See, there you go, and it'll open up all of these relationships, which are all questions. So questions are related to this. If you look at the schema, you'll see this. And then we can expand, for example, this comment again, and it's going to tell me already that there is one ask relationship, three commented ons, and probably no tag relationship. But let's just expand all of these. There you go. And this is like a graphical way to explore everything. And I think that will conclude my part of the talk. I'd just like to thank one of my colleagues from Paris because I stole a lot of his slides. He's got Florent Bifil. He's an amazing person. Even though he isn't here, I'd still like to thank him. And I'd now like to invite my colleague on the stage, Siddharth Agarwal.